Good afternoon, everyone. Welcome to this webinar. Let's wait a few minutes that the room fills in and the participants join, and then we will start. So I will share my slides in a moment. I hope you can see them. Yeah, you should be seeing them. So welcome again to this fourth webinar of the EUCloudEdge-IoT initiative organized by UNLOCK CEI project. This webinar is entitled Cloud-Edge-IoT Innovations in Manufacturing, Unveiling Market Insights and Use Cases. We will be together for the next 1.5 hours, and this event is the first of a series of events, both online and offline, that we will dedicate to specific industries, so to specific sectors. And today we start with manufacturing. My name is Marieke Giuffrida. For those who don't know me, I am from Trust IT. I'm a senior researcher there, and I am the communications leader of UNLOCK CEI, one of the two projects that are coordinating the EUCloudEdge-IoT umbrella initiative, as we will explain in a moment. Together with me today, we have a full lineup of excellent speakers. You see them, you see their faces in the slide here, but also you see them as speakers in the event. I will properly introduce them once it's their turn, but just to give an overview, we'll have a first part of the event that's focused on setting the scene. So we'll have presentations from first Golboo, coordinator of UNLOCK CEI, who will give some information about manufacturing trends and about the UNLOCK CEI project. Then we will have another presentation from Marieke Rohde from VDE, another UNLOCK CEI partner, who will present the industry requirements and data-driven value streams in manufacturing sector. Then we will have a special focus on use cases. So we'll have two use cases from two projects from the Meta Operating System cluster that are co-organizing this event with us. So we will have Eneko Rada from Innovalia presenting the AerOs project use case. And we will have Guillem Gari from Robotnik representing the FluidOS use case. And then we will have the last part of the event, which is structured as a panel discussion with use case presenters, but also new panelists. So Guillem and Eneko will be joined as well by Ignacio Lacalle from Universitat Politecnica de Valencia, also part of AerOs project. Then we will have Clara Pezzuela from Fireware, Maria Rossetti from the MAID Competence Center, and Alissa Zaccaria from Intellimec. We will have also some time for you to ask your questions or comments, which are very much appreciated. In case you missed our previous events and webinars, you find here the links to them. Okay, so we had already 3 webinars from UNLOCK CEI and many other events you can find in our YouTube channel, which is dedicated not only to UNLOCK CEI, but to all the projects in this umbrella initiative. And here you find some a list, let's say, of the upcoming events from the community. Okay, starting from tomorrow until the 27th of September, we have already many events, and you can find them all in our website, www.EUCloudEdgeIoT.eu. Before starting, please remember that this session is recorded. So if you don't agree with being recorded, you will need to leave. But if you agree, we're very happy that you can stay. And I would like to encourage you to engage with us. Okay, so we would like this to be as much interactive as possible, although it's an online event. feel free to use the chat and the Q&A function whenever you want to ask questions, to put your comments, to share your perspective, and also just use it already right now to present yourself, okay? So just tell us who you are, where you come from, why you're joining, what's your company, and also if you like, you can include your social media profiles in the chat so we can, you know, maybe interact a little bit more and follow up later. So that's all for the introductory remarks from my side, and now I will leave the floor to Golboo for the first presentation.
Thank you very much, Maria, and good afternoon, everyone. Welcome. Let me just share my screen. I hope you can all see my screen now. Okay, yes. So thank you. So my name is Golboo Pourabdollahian. I'm a consulting manager in IDC, and I'm the coordinator of UNLOCK CEI project, one of the CSAs of EUCloudEdge-IoT initiative. Today, I'm gonna walk you through very quickly through the UNLOCK CEI itself, the project, and some results of the first years that we have already achieved in terms of trends in the Cloud-Edge IoT market in manufacturing in Europe. So very quickly, who we are. UNLOCK CEI is a coordinated support action project funded under Horizon Europe. We started more or less 1 year ago in June 2022. And our consortium consists of 6 partners. We are going to run for 30 months, and together with Open Continuum, which is the other CSA in the EUCloudEdge-IoT initiative, we create the umbrella that you can see here on the right of EUCloudEdge-IoT. So basically, the EUCloudEdge-IoT is an initiative which has been created and motivated by the European Commission. It has several objectives, but the main objectives are related to creating pathways to understand better the development of Cloud-Edge IoT solutions across the computing continuum. Also to promote cooperation among different research projects that exist in this portfolio, because there are many projects in different clusters, from MetaOS to cognitive cloud to swarm computing. So one of the important missions that EUCloudEdge-IoT has is to boost collaboration among these projects. And finally, to support the definition of larger scale pilots. As I said before, there are 2 CSAs that coordinate EUCloudEdge-IoT. UNLOCK CEI, which is the project that today we are talking about, which covers the demand side, and Open Continuum, which covers the supply side. But before going to the market trends for manufacturing and some results that we want to share with you, just to give you an overview that why UNLOCK CEI is born, what is the motivation behind this. So the reason is that, and the fact is that the adoption of and the spending on Cloud-Edge IoT across Europe is really increasing. So here you can see some numbers in terms of the spending across European companies for Cloud-Edge IoT in 2022. And the forecast shows that in 2026, the expected spending on Edge will reach to $75 billion in Europe. So this is a big number, but the problem from the other side is that still the industrial stakeholders are having trouble to go on with implementing and adopting these solutions. It's not an easy paradigm change and paradigm shift to going towards the open computing continuum. And so that's why UNLOCK CEI is born. The mission of UNLOCK CEI and the vision of UNLOCK CEI is to really understand what's happening in the European market and to accelerate and facilitate the deployment and implementation of Cloud-Edge IoT adoptions across the computing continuum by understanding what are the drivers, and most importantly, by understanding what are the business opportunities for European stakeholders in future for Cloud-Edge IoT. And so to do this, we have 5 main objectives in the project. You can see them here. First of all, assessment of the demand landscape of the Cloud-Edge IoT, then to define some market scenarios and guidance, to understand what could be the potential scenarios and pathways of the market. then to establish a dialogue between the industry and technology providers, so to get engaged directly with the industrial stakeholders. And then obviously as a CSA also to coordinate with the supply side, with the portfolio projects and technology providers, and also raising awareness. To do this, we focus on, in UNLOCK CEI, we focus on 5 sectors, which are the, for Cloud-Edge-IoT, there are the most relevant and strategic sectors, so agriculture, energy, healthcare, manufacturing, and transportation. And today, basically, we are focusing on manufacturing, but then there will be other webinars for other sectors as well. So let's see that what's happening in the manufacturing market in Europe in terms of computing continuum and Cloud-Edge-IoT. So these are the information that you see here, the data that you see here is the result of the UNLOCK CEI survey that we did within the project, doing 700 interviews with industrial stakeholders and companies. So as you can see here, the adoption of the solutions of Cloud-Edge-IoT is increasing across Europe. Still, it's really very limited, especially if we are talking about technologies which are on edge. So as you can see here, the current edge adoption is really small, so something like 9%. But what is interesting here is the plan of companies to adopt and to move towards edge or to distributed computing continuum in the next 2 years. And as you can see, there is a huge potential for the computing continuum and moving the resources towards edge according to the results of the survey. But what are the drivers that push the companies for such a paradigm shift? Here you can see the results of the survey in terms of the main benefits of edge by industry. So as you can see here, for some industries, some drivers or some reasons are much more bold and valid. But for manufacturing, what is interesting here, you can see here, is that there are some drivers which are more or less at the same level of relevance for manufacturers. So the most important one, the driver for manufacturers in Europe to go towards edge, is to improve their security and compliance. Basically, this is due to the reason that when they're implementing edge, so the data is not traveling. Then there are also other important factors to encourage them to move towards edge, such as the reduction of the volume of data across the networks. Another important thing is that going towards edge help them to deploy the AI and analytics model more closer to the device on the edge. And then also the low latency. So these are, let's say, the main drivers for European manufacturers to move towards edge. But this deployment and this adoption of the Cloud-Edge-IoT solutions happen obviously at the level of use cases. So we should always start at the level of use cases. And that's why we also try to understand that what are the most adopted use cases currently in manufacturing for Cloud-Edge-IoT, and what are the most relevant ones for the future. So here in this chart, you can see that as the most adopted ones currently, we have asset monitoring, maintenance, and repair. We have manufacturing operations. We have employee safety, and also fleet tracking. These are the ones which are more adopted currently in Europe. However, with the ones that we see at the end of the chart, such as AGVs, such as food traceability, such as process automation, even though we see that the adoption level currently is not really high, but the opportunity for future is quite significant, because if you look at this chart, you can see that many of these use cases which currently are not adopted, such as AGVs or such as process automation and optimization, are expected and planned to be adopted by the companies in the next 2 years. So basically, these could be really the spotlight use cases for technology providers to focus on in order to be the promising use cases in the next years in Europe. So let's say if we want to make a concrete list of top 4 use cases for manufacturing for cloud edge IoT, we can talk about these 4 use cases. These are based on different factors, not only the level of adoption and the level of future adoption, but also in terms of the spending of the companies on cloud edge IoT, in terms of the strategic relevance of the use cases. So these 4 use cases, as you can see, are asset monitoring and maintenance, which is currently adopted very well across Europe, then autonomic operations, then AGVs, which will be really a very interesting use case in future, visual inspection and quality control, which currently is being used, but not that much, and we expect that it's going to be really adopted much more in future. And as you can see here on the bottom of the slide, these use cases can be obviously implemented across the computing continuum. So for some of them, like asset monitoring and maintenance, the workload can be distributed moderately between cloud and edge, while for some of them, like AGVs, the workload will be distributed more towards the edge. So really, it's the matter of use case that how will be the distribution of the workload, and what could be the benefits that this distribution would bring to the end users. If I want to go very quickly, I just skip, sorry, because I don't have much time, to what's the final message, what's the way forward to go with, is that IoT and edge use cases are still really at the beginning. So a very small scales, according to the results of the survey that we did, less than 25% of companies that already using these technologies are using them at a larger scale. So you can see that really the potential is there, but there is still much work is needed in order to implement these solutions at a larger scale. Then, like any other technologies, there are top barriers for adoption of cloud edge IoT. One of the most important ones is the lack of adequate IT infrastructure. We are talking about computing continuum, but honestly, if we go into the detail of it, we are not still clear that what are the adequate IT infrastructure that we need to implement the CI use cases. Security is still a big concern. Cost of deployment is a huge concern for many of the companies, especially when we go to the edge. And another one is lack of skills. This is also something which is very relevant. From another perspective, the current solutions are really complex. They are costly and they are slow. And in most of the times, the technologies which are related to these solutions are not mature. And from the ecosystem perspective, the ecosystem is still very fragmented and evolving. However, this doesn't mean that there is not a bright way forward. It means that all these challenges are opportunities for technology providers from the supply side in order to make solutions that could address these challenges, be less complex, less costly, having a more integrated ecosystem, and going towards a much better adoption of this solution across Europe. So I hope I was in time, Maria. Just one last word. If you want to read more about our reports and our let's say insights from Unlock project, you can just go to the website and read our reports. And I'm done. Sorry, Maria, to be over time.
That's great. That's perfect. Thank you, Golboo. I will copy the link you were mentioning also in the chat. And thank you very much for those who are writing in the chat and presenting themselves. Now, if Marieke is ready, I would like to leave her the floor for the next presentation. Okay.
Hello. Yes. Thank you very much, Maria. Yes, I'm just sharing my screen. Can you see it all right?
Yes, we can.
Yes. Okay. Yeah. Great. Yes. On top of the survey that Golboo mentioned, we also entered a dialogue with stakeholders from manufacturing in order to identify promising use cases that we could also recommend to the European Commission for like kind of being funded in large-scale pilots. So to this end, we conducted an interactive online workshop with industry associations and stakeholders. And on that workshop, one participant from a German applied research institute presented an asset monitoring use case, and then the participants discussed. And to drill down even further, we followed this up with 2 interviews. One with cloud edge technology provider from the aerospace sector from Germany, and one from the Italian metal sheet manufacturer SCAM with their service provider Intellibec, who I believe are here today as well to talk about their work directly. From these, the workshop and the interviews, we derived the value chains and networks, as well as the service requirements from the demand side. And what we found resonates very well with what Golboo just presented. So at the moment in manufacturing, especially where small and mid-sized companies are concerned, the use cases are all internal use cases where you don't actually use edge technology, cloud edge technology to share data along the value chain. So it's like IoT and robotic solutions mostly. I will just to make up some time. Yeah, I mean, another really important thing to mention on a holistic level is that the solutions aren't really transferable very much. So these are often like individual solutions because and one thing that also Golboo mentioned is that standardization lags behind. So you can't technically port a solution from one setting to the next, but also like just every production line is different. So these are very kind of individual solutions, which kind of makes the market uptake a bit slow. And the rest is stuff that Golboo just said. So just to come to the solutions. So these company internal use cases, they have 2 main stakeholders, which is the manufacturing company SME decision makers, I call them. So they are the main beneficiaries, and also like the kind of point where everything comes together. They pay everyone involved. And their main partner is like a solution provider, a cloud edge solution provider, who then orchestrates like the interaction with all the other stakeholders. Then you have also, because these use cases are so internal, we broke it down a bit further and identified as other important stakeholders, also just the tech staff at the manufacturing company who are important in that scenario, and also the domain experts who are also beneficiaries of these solutions, or should be, like they are really critical that solutions work for them. And then you have the grown existing IT landscape, and you have your new cloud edge solution, which has to be integrated there. And this is the main job of this service provider, the system integrator up front. We also included the OEM, or the kind of big client of the mid-sized company there, because they give important requirements down the supply chain. Like, for instance, the Supply Chain Act is coming, so there might be more transparency requirements in the future. So companies prepare for that. In one of the interviews, there was also another kind of more future-looking use case mentioned, which is like an after-sales use case where you actually try to use product data along the product life cycle. Let's say you have a intelligent car and you use feedback from that car in order to provide customer service, or also to manage the life cycle of your product, or like improve your product. These kind of future-looking use cases, they're, I think, very relevant and hold a lot of value. This is what the stakeholders mirror to us. So we included those as well, not as something that will happen tomorrow or in a year, but something that is really relevant in the kind of bigger picture. I try to rush. So this is not just driven by the desire to be more economic. Company stakeholders take up these projects also to have competitive advantages. A very important driver of innovation is a skilled labor shortage. This is why also the domain expert is such an important stakeholder, like really a gatekeeper. And another concern of the manufacturing company decision makers is to prepare for a changing market. Like the decarbonization of manufacturing will change established processes. There are new demands from the main clients, and just company resilience has to improve in the light of changing world order and everything. And so the service requirements directly derive from everything that Golboo and I just said. So for the design, it's really important that there has to be like cheap solutions, because the SMEs just can't afford to make big upfront investments. They have to be tailored to the operation environment. They have to work for the staff. Then I'll summarize a little bit the most important ones, because we're already running late. Really important. This is a massive one. Is it has to the solution has to work robust, and this is also where edge computing comes in as an important factor. So the technology works in real time, even if network connectivity isn't great, even though data volume is large, and it has usability has to be good. There shouldn't be any operational failure, really. And another very critical demand or requirement is that the system have as little maintenance requirements as possible, and that also the manufacturing staff or the on-site staff be trained to perform basic maintenance and updates by themselves, because they can. It's really expensive for them to always call their service provider. So I'll jump to the conclusions. So for the funding, this means that you really have to look at manufacturing in a two-stage way. Stage one is you have to boost the CEI technology readiness company by company by funding individual CEI innovation projects. But this is, of course, not a large-scale project, but by supporting standardization initiatives, by approaching solutions that focus on lifecycle management or on domain experts as end users, by supporting projects that improve the infrastructure robustness and reliability. And then you have sort of, once a sector is ready, you have these very visionary use cases across the supply chain, where you tap the real potential. And there you should, of course, watch out for like pioneers who are entering that domain anyway. And just before I stop, I should mention that this mostly concerns small and mid-sized companies. Of course, large companies probably are a bit further along in the process. Thank you very much for your attention.
Thank you very much, Marieke. We are actually quite on time, so good job on that. And now we pass to the second section of the event, that's presentation of use cases. So Marieke, you should stop sharing the screen so to allow our next speaker, Eneko, to share his own slides. So we have the first use case presentation for Cloud-Edge-IoT manufacturing from AerOs project. We see Eneko's slides now. Okay, so Eneko, the floor is yours. Thanks.
Okay, thank you, Maria. Hello, everyone. Good afternoon. So in this presentation, I'm going to present AerOs manufacturing use case. Okay. This is quite interesting because we have like 3 different scenarios, as I will later explain. But at this specific presentation, I will give further detail in one of these scenarios, which is more related with metrology and quality control. Okay, visual inspection for manufacturing lines. First of all, it's worth to say that we have different elements in manufacturing use cases. We have some micro edge sensors, actuators, and processing units which are located in the edge level. But here we have also cloud elements which are related, for example, with some kind of data that are sent from our edge sensors the cloud. Okay, just to start with AerOs use cases, in this pilot we have, as I previously mentioned, 3 different scenarios. Okay, these scenarios are interrelated. Okay, they are all related, of course, with manufacturing. The scenario 1 is the green manufacturing and CO2 footprint monitoring. The main goal for this is to implement edge intelligence services to optimize impact and footprint of modular production lines for drones. So here, AerOs will be used in a drone production manufacturing line in order to not only monitor the CO2 footprint depending on each of the parts of a drone, but also to predict and to optimize the production paths for each individualized drones. Okay, so by this, we are also generating a kind of DPP, a digital product passport, in order to make these drones more sustainable. The second scenario, and this is the scenario I will later give further detail, is the automotive smart factory zero defect manufacturing. This is for quality and visual inspection of a manufacturing line, and this will enable the seamless interaction of quality control intelligence engine with a wide range of dimensional instrumentation equipment. I will later give further detail on this. The third scenario is related with autonomous ground vehicles. Okay, this actually we have in the room Maria, which is responsible of this scenario. Maybe she will later give more detail on this, but this will provide on the fly AGV's decision making and robot path calculation. This will allow, of course, to have a more dynamic production line as well, because the AGVs will be more adaptive depending on what we need at each moment on a production line. Okay, now going through the second scenario, the visual inspection and quality control use case. The idea here is to implement AerOs capabilities for dimensional measurement process of physical components. Here we have a CMM, a coordinate measurement machine, that will allow us to read the dimensions of any pieces by a laser, and will provide us a complete overview of the dimensions of a piece, and also to analyze all the data related with the machine, the production, and the piece. Okay, so here the main objectives is to promote the manufacturing autonomy level 4, okay, and remote operations of CMMs. Of course, AerOs will allow us to have fast data processing and human-assisted automated decisions. Okay, I mean, with this we mean that maybe we have to change some production steps in order to change some dimensions of a specific piece. For example, for these use cases will be run in Innovalia Directive Factory at Automotive Intelligence Center, and this is located in Bilbao, Spain. Okay, now what is the main challenge of this specific scenario? As you can imagine, currently in the production lines, we have a lot of dimensional data related with different pieces. Of course, the pieces are more and more complex, and we have more and more quantity of pieces. So if you mix everything into one problem, here nowadays we have a lot of data sets in less time to analyze. Just to give you an example, we have for a car door, for example, we will have 15 million points per piece. Okay, so this involves high accuracy 3D point clouds of any products. So as you can see here, we have more and more data to be analyzed in less time, okay, in a production line. So in this next slides, I will present you the process as is at this moment, what process do we have currently, and what do we envision for AerOs when it's implemented in these use cases. In the dimensional quality inspection process, we have like 4 main steps. I will give further detail on each of them, but in general, at general level, we have the capture of point clouds of a piece. We have the digitalization, or maybe it could be a digital twin generation of a piece. Data analysis, we can compare the real dimensions of a piece with what dimension should have depending on what tolerances do we have for each of these product. And finally, the analytics, the results and reports of each of these pieces. So in this scheme, you can see the traditional method for the realization of a measurement. Okay, so as you can see here, the first step will be to take the CAD file of the part to be measured. And in this step, we analyze the dimensions and the tolerances to be measured and identify which machine and technology is the best to do the measurement, because we have different sensors, different machines, and this has to be selected. Okay, so this is the first step. Okay, now the second step. This is more related with the definition of the geometry and dimension. So here we define the geometry, dimension, tolerances, and create the quality information framework. Okay, these steps consist on transferring the dimensional information from the CAD file to the software, which is called the M3 software design program. So as you can see in the video, we have to include this information manually at this moment. Okay, here we are including information. Perfect. Now, the third point, the third step here is to define a measurement plan. This is based on the definition of the points of a piece to be measured. This depends, of course, of the experience of the metrologists, but we have to choose here as well the external conditions under which the measurement is done. For example, we can choose what light conditions do we have at this moment, because this will affect to the measurement, and we have to choose the exposure time for the scan or the scan density. Of course, in the video you can see here that in the software we introduce those parameters, okay, the density, the light conditions, and so on. Now, if we go to the fourth step, this consists on defining the matching trajectory. Here we say the machine what steps we need to carry out in order to have a successful dimension measurement. The fifth point is the simulation. Here we simulate the trajectory of the machine that depends on the previously added parameters. Okay. The sixth point, we do the measurement itself. Here we run the measurement in the piece, as you can see here, and here we will obtain the point cloud that afterwards will be analyzed in the software. Okay, finally, the point 7 is it analyze all the data set that has been generated. Here we may have a problem because sometimes if the selected variables that were chosen in the measurement plan are not the right ones, we could get big errors in the measurement, and all the previous process must be repeated. So as you can see here, we have from one side a quite manual process, and on the other side a very heavy data volumes for the software to be analyzed. So what challenges do we have here? We need experienced metrology. There is time-consuming process, and we have increasingly big data volumes, 3D point clouds, and a lot of production lines, different pieces. If we go to modular production line trends, we will get more and more data. So this is a very big challenge. But what opportunities do we have with the implementation of AerOs? Here we will have the ability to include specific application and fast applications in the edge in order to automate and assist the process for the metrologist. Of course, we can even include some artificial intelligence applications in the edge in order to get optimized measurement plans. And this, of course, all of this could be with a low latency or even real-time operation. Okay, so here you can see the general scheme of what do we envision from AerOs to these use cases. So from one side, we have the CMM, the measurement machine operations. We will send some pre-alignment and sensor data parameters to AerOs, which will allow us to run some edge artificial intelligence applications, low latency applications in order to have measurement reports analytics and optimize CMM sequences and paths. Okay. And this is my last slide, just to finish. What is AerOs motivation from this specific scenario? From one side, we will have an effective data management because, as I have previously mentioned, we have big data volumes from meteorological and dimensional parameters. Okay, this will allow to run explainable artificial intelligence application in the edge, and this will be done nearly in real time in order to optimize CMM configurations and parameters for the best measurement and point loss. So this will save us a lot of time and resources. On the other side, analytics. This will allow not only to analyze the performance of the CMM and to allow us the predictive maintenance of CMM components, but will also allow us to detect some anomalies and optimize the measurement sequence, which is related with the previous point. Finally, AerOs will provide us a management toolset in order to promote its predictive maintenance, as I have previously mentioned, and will allow a dynamic management of all the CMM components. Okay, so this is very important for us because now we have a very manual process. So this is all from my side. I think I'm on time, Maria. So thank you all for listening.
Yes, thanks, Eneko. You're also on time, and we see some virtual applauses for you and for the speakers before you. Now, same approach. So if you can stop sharing, I will give the floor to Guillem for the presentation of the FluidOS use case. Thank you.
Hello, everyone. My name is Guillem. Sorry, my name is Guillem Gari from Robotnik Automation. I am part of the research and development team of this company, and I will present one of the use cases of FluidOS. This is robotic logistics. Okay. So, what is the motivation of this use case? Is basically with mobile autonomous mobile robots. We have some constraints that we don't have in the static computational world. That when I mean static, is not moving computers. So what we do in logistics robotics are quite complex, and we run complex algorithms in a constraint in several ways machines. So with FluidOS, what is the motivation? What we wanted to achieve? One is to increase the computational efficiency by dynamically orchestrating the robot workloads. It will impact in reducing cost, and also it will give us more CPU to run more complex algorithms. Also is to enable the computational to be outside the robot. That is not likely in the traditional approach. So the idea behind this is to reduce the power consumption in order to increase the autonomy of the robot. Also, another thing very important is to reduce cost of the especially on the deployment, is because deploying a robot could take a long time. So we wanted to reduce it from 1 week to 1 day. So the idea also is to increase the computational efficiency, as I said before. So what is for us a robot? It's a mobile robot at the moment. What we do is we have several devices inside the robot, and we have some workloads workloads instead of a piece of software that that are intrinsic related to the robot and it cannot be moved away, and some of the other workloads can be moved away. So we have also several devices like CPU and industrial router, wireless connectivity or mobile connectivity, and also we have different kind of sensors connected to the LAN. And also very important, we have a battery powered device. So energy consumption is important for us in order to increase productivity. So what are our locations here in the way of the computer continuum, the cloud edge continuum? So for example, in our use case, the servers will be on Robotnik facilities, and also the cloud will be in the cloud, the traditional cloud providers, and each warehouse where the robots transport goods from point A to point B will be a different location. So each location will be independent, but they are connected to the internet. So this is the typical topology of the robotic fleet. All robots are connected to a router, to a, I don't know, mobile access point in order to interact with the edge or eventually with the internet. So this is the way that that traditionally goes, and this is the way we are going to use it in this use case. Well, we have several robots. So in order to manage several robots, we need some kind of software that usually runs on the edge that manage the different robots in order to optimize the work, the transportation of goods or the missions. What are the communications between the robot and the fleet management system? This is the software I've been talking about. Is they give them some status, what are they doing, and also the fleet management system will ask some robot to do a mission, and the mission of this fleet management system is to find the optimal robot to do the assigned mission. So it will search for the ideal one. So in the traditional approach, what are the limitations? So traditionally, robots only run their own processes, cannot run processes from another robot or another devices. Also, the robots are running the most of the processor either are needed or not. So this will decrease the performance of the whole system and then increase the energy consumption. So also, the software is not deployed in a standard way. So each manufacturer of the robot deploys its software in his own way or its own way. So there is no easy way to learn how the software is deployed, and this is a big problem. So, and also the robots, because of the battery power nature, are limited in computational capabilities because we cannot put high-end computers over there because they will drain our batteries in order to not allowing the robot to work. Related to the last point is the robots are limited in computational energy consumption. So the robot cannot run anything on their own because he will drain the battery, or even he can it can be overloaded and not able to handle their own processes. So also the workloads always are done on the robots, and they cannot access to higher end or server grade equipment in order to have better capabilities to run the algorithms. What we wanted to do with FluidOS is to overcome these limitations. So FluidOS will provide us a way of defining the rules that determine the behavior of the robot in order to optimize the computational workloads and energy consumption of the overall fleet, especially of the overall fleet, because we need to optimize not only one robot, overall all the robots. So FluidOS also will give us some intent approach definition of the workloads, attending specific metrics like network quality, battery level, or robot status, or in the future even more, something that the implementer will decide. Also, FluidOS will provide a way to increase the autonomy of the robot by dynamically switching on and off or offloading workloads independently of the application. So this is done outside the robotic world. So it will be done in the cloud on the FluidOS world. So it will release the robot developers to do that. Also, FluidOS will allow the robots to extend the computational capability by delegating the workloads to a core powered. I mean that something is plugged to the electricity, not with batteries, with high end on edge or cloud without compromising the autonomy. It will be done by computing these workloads outside the robot. So here you are a robot state rules example that we wanted to apply in FluidOS, but could be anything else. So, for example, our metrics is the robot state. We define 4 states: idle, ready, emission, and charging. Idle will mean that the robot is not running, is not doing anything, but it has not everything loaded at the moment. Ready is almost the same, but it can be asked for emission. And emission is like is performing a task, basically to move things from one point to point B. This is the traditional logistic robotics. And the last state is charging. Charging is when the robot is recharging the battery. And the idea is these states have different specifications. For example, the idle and ready. The idle, for example, can accept foreign workloads for another robot or for another devices. But ready or emission cannot accept any other foreign workloads. But charging, for example, is the most free state. It can accept foreign workloads, and it doesn't need to run some processes in order to save a battery, or in order to reduce, in order to make the charge faster. So we can use this robot as an edge device. So I think I'm on time, and that's it for my presentation. Thank you. And I leave the floor to Maria again.
Yes, thanks, Guillem. Yes, you are on time. Thanks for all the presentations to Guillem and the other speakers. Now we can move to the last section of the webinar. So next 30 minutes more or less. So I invite all the panelists to please turn on your camera again. So we have Guillem with Eneko that you have just seen, but we also have Ignacio Lacalle from UPV. Then we have Clara Pezzuela from Fireware, Maria Rossetti from MAID Competence Center, and Alisa Zaccaria from Intellimec. So we will have now a panel discussion with all these people. The panel discussion will be basically split in 2 rounds of questions. So just let me remind the speakers the rules. I will ask a question, each of you, and you can reply in short answers, okay, 2-3 minutes. So it's like a debate. And if anyone from the audience wants to add anything or ask additional questions, do it in the chat or in the Q&A box. So let me start this panel discussion on Cloud-Edge-IoT in manufacturing with a first round focused on the present, and more specifically on, we have listed a lot of requirements, a lot of opportunities, but also a lot of requirements, needs, and challenges for the implementation of these solutions and use cases. So first round will be focused on current challenges, and I'd like to start with Guillem, as you already just presented your FluidOS use case. So my question to you is if you can elaborate a little bit more on what are the specific challenges that you are encountering right now for the development of your use case, so your needs and your requirements at the moment.
Yeah, thank you, Maria. I think the bigger challenge we have here in robotics logistics is network reliability. At the moment, we cannot offload some of the loads outside because we have black spots or some places that we lose connectivity to an external devices. So this is one of the problems we have. Another is like the opposite nature of the architecture of the robotic software or the robotic middleware we are using and the cloud technologies network architecture. They are colliding. So it's complicated to make these two worlds work together, but something we are working on it, but it's not an easy thing to do that. So, and the last but not least is like a lot of people in robotics are robotic developers, and they have a lot on their plate. So they have to do complex algorithms, they have to deliver things on time, and when we ask to do something about cloud technologies, they feel frustrated because this is not their field. This is not something on the top. They don't barely understand. They are robot proficient, not cloud proficient. So this is the current challenges we have. Thank you, Maria.
Thanks, Guillem. And now I would like to also hear the perspective of the other use case that was presented. So from the AerOs point of view, I will ask this to Maria Rossetti from MADE Competence Center, because they're also partner of AerOs, regarding some of the activities that you are doing currently for AerOs in terms of testing facilities, which are of course an important element also to overcome the challenges of a use case. So Maria, can you tell us what's your role in the specific AerOs for testing activities?
Yeah, first of all, Maria, thanks a lot for the invitation and introducing us to this interesting panel. MADE Competence Center is participating in AerOs together with Polini Lab 4.0, and Walter as technical manager is here representing also the use case by providing testing facilities for intra-logistic scenario. And I will leave the word now to Walter to define what are the main challenges, which are at the moment basically technical.
Yes, I thank you, Maria. Thank you both Marias for the introduction. I hope you can hear me well. Well, basically the challenges are on our side, not so much on networking, but on data availability. And it is something that we face in MADE, since MADE is closer to in real industrial world, and closer to real industrial world means lack of data availabilities. So I saw in the previous presentation from the colleague of FluidOS that we were using some data models for robots for dynamic allocation. Well, like in a lot of HVs or modern manufactured robots, those data are not available for companies. So that's the reason why we are using our facilities in Polimi as a test bed to make some tests and to understand which is the minimum viable set of data which can enhance the opportunities of our project to make this available made on a real industrial robot in a second iteration. And that I would say is the main challenge that we are facing, or at least the challenge which is more effort consuming from our side. I hope I stayed in the times.
Yes, Walter, thanks. You did. So we have another panelist actually from me. The welcome also from my side. And I would like to continue this first round. So we have talked about challenges. You've mentioned data at the moment from a use case perspective, but there are challenges at any level we move. So passing from use case perspective to a specific company perspective, okay, because we have companies that are developing the use case, behind the use case. So I'd like to ask Eneko, focusing more generally, okay, on a company perspective, what do you think are the barriers that companies are encountering these days when it comes to implementing and integrating all the technologies that enable, you know, integration and the continuum, computing continuum concept? What would you mention based on your experience and perspective?
Yes, based on our experience, I would say that there are like three main barriers, I would say. The first of it, I would say, it's the IT infrastructure. The second one, I think, will be like the human resources that we have around. And the third one is the cost. I mean, when it comes to the IT infrastructure, we have seen like some companies that have outdated technologies implemented many years ago and are still an important part of their processes. So, for example, for instance, it will be like all monolithic resource management softwares that do not allow any connectivity or any data sharing. For example, in some cases, another barrier could be that some companies have machines that lack any connectivity, okay, or any PLC or any level of automation. I mean, everything is done manually. So there are still lots of manufacturing companies that fully rely on these technologies, and I think that the implementation of new technologies, smart technologies, will have a beneficial impact on them. So the question here is how those new technologies can be adapted to those old non-digitalized machines, or what IT infrastructure will be needed for them, or how new IT infrastructures could be implemented on these old legacy systems. Or maybe we can say that how cognitive technologies may be incorporated in all machines. So I think there is a big challenge there. On the other side, we have the other problem, which is the human resources. So here, manual workflows rely on humans to perform critical tasks manually, as the name suggests. So the main barrier here, I would say that is how can workers be fully trained on new technologies, having in mind that in some cases their knowledge, their technical knowledge does not include the current trends on these new technologies, and how can be a new training design in this technology. There is a very difficult question here. And finally, the cost, just to finish with my contribution. When it comes to the digitalization, as we have seen in some of our customers, when it comes to the digitalization of a company, we should try to minimize those costs. And for that, we should analyze different things. For instance, it could be we should evaluate their needs and their goals on the digitalization and choose the most suitable technologies for their situation. And they also should look for expert guidance for this and support during the process. That will be an interesting solution for them. Okay, so yes, this is my answer.
Thanks, Eneko. Yeah, you mentioned many things, and I was wondering if any of the people who are still joining the event from their company perspective, if they share your view, or if they would add any other barriers or challenge, okay, to the ones that typically a company would face. So if you want, people that are still online, feel free to share in the chat also your perspective, okay, on this question. And while you type it, I see that Marieke has also made a question in the chat. I will leave it for the end, and we'll continue for the time being with the other panelists for the first round. So enlarging again the perspective about the requirements and the challenges from a company perspective to a more industry perspective. I would like to ask Alissa, what are the current challenges that industry companies, because you have a privileged point of view as a consortium association of companies manufacturing. You can see many different actors. So what would you mention as the main challenges for them in adopting and implementing use cases for CI in manufacturing?
Yes, thank you. We have supported several companies in this process, and actually I fully agree with Eneko concerning the main barriers. Maybe I can summarize it in the difficulty in building a sort of cost advantages analysis. So to evaluate the return on investment, let's say that the cost is very difficult to be evaluated, both for the uncertainties connected with old and outdated assets and infrastructures, which may require a retrofitting process. And this is, of course, a big uncertainty, and also concerning the training of employees. This is commonly neglected, but it's a very crucial process, and it implies significant cost. And also, if you plan a very good training process, the acceptance of employees towards this new technology cannot be taken for granted. So uncertainties are huge, and they are countered by not very clear advantages. So I think that sharing best practices with quantitative information on the opportunities connected with this technology is very crucial. And also initiatives for supporting industries also from the financial point of view to support this transition phase is important. Also because, as I said before, as I said in the chat, I think, maintenance cost and constant updating, since we are talking about evolving technology, has to be taken into account, and it implies cost for industries. So financial support is crucial also, and this is why we usually participate in Horizon projects also to support financially our companies which wanted to build these use cases. And this is what we do, for example, in the AI Ridge project. And for this, maybe I will share in the chat the link for the final event that we will have in September in Bruxelles, where we will show some of our use cases.
Yes, thanks, Alissa. That would be great. Feel free to share this in the chat, and let me, leverage a little bit on what you just said before leaving the floor to Clara, because you mentioned, something very important, that to overcome these challenges and barriers, we need good examples, we need use cases, and you need, some sort of success stories, and we need financial support, let's say, to build these success stories. So from the UNLOCK CEI perspective, we have two initiatives coming up in September. One is a meet and greet event on open calls that these projects are also MetaWise projects are organizing to support people interested in this field to get funded to continue working. And on a UNLOCK CEI point of view, we will have a final event on 25th of September, so very close to yours. Sorry, can some the other people mute? Okay. We'll have this event where we will share success stories and use cases and implementation, maybe something similar to AI Reggio. So I will put the link in the chat as well. Now I will like to ask to Clara instead to close this first round of questions to bring Clara your perspective as Fireware specifically on the topic of data spaces. So what are the key requirements of data spaces to be integrated in the computing continuum? And this is something that also Natalie in the chat was also mentioning, the data spaces point of view. So please tell us more.
Yeah, thank you, Maria, for the invitation. Yes, indeed, I think that the first thing is to explain why we are talking about data spaces in this webinar about computing continuum in regards to manufacturing. And I think that the reason is because on one side, most of the data that we are managing or trying to share in data spaces are coming from devices that are exactly in the edge, in the IoT, in the cloud. So it's a kind of support for the data that we are managing. And on the other hand, because once the data spaces will be set up, they will be somehow deployed across the continuum. So it will be deployed either in the cloud or in the edge or anywhere. So I think that's the reason why data spaces are relevant for the spectrum of computing continuum as well. And particularly there is data spaces manufacturing. So that's why also it's of relevance for this vertical. So regarding the challenges that you are asking me about data spaces in regards to the continuum, I could say that the first challenge is to allow people to understand exactly what is a data space concept, because not always is very clear what we are talking about when we talk about the data space. And it's not only technology. When we talk about the data space, are we talking about an ecosystem? Are we talking about the governance that is managing this ecosystem? And of course, we are also talking about functionality. We are talking about digital infrastructure to run this data space, but it's not only technology what we are talking about. The second challenge is to understand why a data space is needed. Why do I have to share my data, or why others would like to share data with me? So here the point is to get the value of the data spaces. In some cases it's because I want to share my cost. In other cases it's because I'm going to address an added value service that I cannot do it alone, so I need to share my data with others. And in other cases is because I want to reach a common goal with others. So I need to join my data with other data in order to get this common goal. And for me, two important challenges when we are talking about data spaces is trust on one side. So if I'm going to share data and others are going to share data with me, this has to happen in a trustworthy environment. And second, interoperability, because if we are not talking about common standards, if we are not talking about common models, shared APIs, we will not be able to share any data, and we will not be able to be interoperable. So we need a minimal set of rules, a minimal set of criteria in order to share. So that's would be my challenges for the continuum in regards to data spaces.
Thanks, Clara. And I would like to stay with you also to start, the second round with you, because since we are mentioning data spaces, the second round of questions is focused on the future perspective and the way forward. So what do you think as we move forward could be the role of data spaces and data space technology to, let's say, enable the collaboration and interoperability among different data and stakeholders? So what could be the role of actually data spaces to make the ecosystem more integrated?
Yeah, well, I think that data spaces is a good landscape where we can put together a lot of technologies in order to reach this common goal of sharing data in a trusty way. So first of all, I would talk about standardized APIs in order to exchange data. So I think that it's true that there are a lot of or several APIs available. So the matter is how to make them also interoperable. The second, I could say, it's about how to represent the data, how to use the same data models in order to allow that everyone speak the same language, so the data is represented in a common way. If we talk about data space, we are talking about decentralized identity management, decentralized trust. Everything is decentralized in a data space. So if we talk about decentralized identity management, we need to talk about verifiable credentials, which are ways to represent data, to represent all the participants in a data space. So we will need also some trust issuers that are granting these verifiable credentials. So and we will need also a kind of universal registry for these verifiable credentials. Otherwise, everyone will use its own registry, and again, you will not be able to access with your credentials to data from others. Also, if we are talking about trust, we will require a decentralized trust framework. So we are always trying to move from a centralized to a decentralized paradigm. And this trust framework should be compatible with the European Commission standards or recommendations like the wallet architecture or the European blockchain. So we need also to have a look at that. And once we have the authorization and authentication mechanisms in place and the interoperability issues already solved, we need to publish the data, we need to discover the data, and then we will need kind of metadata brokers or marketplaces in order to publish and to discover this data. And of course, making reference to descriptions based on the CAT, for example, on the CAT IP. And later on, to make easier this connection to data spaces, we will talk about data space connectors that will be kind of mechanisms that will facilitate the engagement with data spaces and the deployment of data spaces, the connection of organizations to data spaces. So I think these will be or are being more or less the technologies we are talking about in regards to data space.
Thanks, Clara. I would also like to hear talking about, future steps and future opportunities and possibility. I would like to hear the point of view again of Guillem. So I'm back to you, Guillem, for another question on what you think are, the next steps specifically for FluidOS, use case, and what maybe role of technologies or other drivers you see as possible drivers for you to overcome the barriers you were mentioning before.
Well, thank you, Maria. One of the technologies that could help in order to get this done in production ready, not only in FluidOS, is the 5G and 6G network technologies. So they promise that we'll have more reliability and more knowledge of the application of what are you doing in order to provide you a better quality of your services, in order to, as I said, reducing or eliminating black spots in order to have a continuous connections over there. So another thing that I think is important that will help us in the future is the AI learning algorithms that are really trendy at the moment. But in some of the robotic fields and the cloud also computing field are quite interesting, because they can manage complex rules that cannot be done in other way. And also in the robotic field, it can handle, for example, arm path planning in complex situations that cannot be done before. So this is one of the technologies that I think that could help us in our use case. And the other one is more ethereal, but I think that cloud technologies that could be applied not only in high-end servers. It's like something that we can use cloud technology standards in low-end devices like microcontrollers or low-end PCs or I don't know, single board computers or something like that. This will help the development because, as I said, in the robotic field, we cannot use server grade equipment over the robots. So I think that's the most relevant at the moment technologies that can help us with the development. Thanks, Maria.
Thanks to you, Guillem. Now I'd like to ask a similar question to Ignacio. So focusing on the role of technologies and cloud and edge native technologies, what's their role in manufacturing, in your opinion? What benefits and advantages they can bring, especially in the future? Ignacio, you have to unmute yourself.
Yes. Yeah, hello. Now you can hear me, I hope. Hello, yeah. Marianne, and hello, everybody. Thanks for inviting me to this very interesting panel. I am very glad to see familiar faces and also other people from other projects discussing about manufacturing and the role of the technologies that we'll have in the future. In this one, I am personally very interested on the topic. And I would like to say, answering to your question, that the edge native, what we call the edge native technologies, which is basically translating from what has been doing in the cloud native technologies about infrastructure integration, automation, continuous integration, continuous deployment, and being able to use the computing resources in very efficient ways. Translating this to manufacturing, I believe it fits perfectly, right? Because there is the cases where multinational companies have diverse plants or manufacturing plants across the globe or across the different countries or even regions. So one thing that the technology that we propose in AerOs, and I guess that also in FluidOS, very similar one, would be to take advantage of these cloud native principles of distribution, continuous operation, continuous time for availability of the resources, etc., applied to different locations, taking advantage and making the most of the resources available there. And this applies for ranging from small computing devices very close to the robots in a manufacturing plant, equipped within the AGVs, up to computers in the plant or small cloud platforms that the manufacturing companies could have access to. Putting everything together and being able to manage it in a single place would clearly reduce the complications and would help to abstract the heterogeneous resources that are underlying and would help to, for instance, apply better AI services across companies, across manufacturing plants. So you could have your processes being much more optimized without the need of moving all your data up to the cloud, need to do complicated tasks there. You could more easily distribute the workload that what we name in order to apply different inference to help your specific parts in your manufacturing lines to be more efficient individually and in conjunction with the others. That's at infrastructure level, but also from the user's perspective, we believe that helping the IT system administrator and the user of the manufacturing, the stakeholder, to understand their computing capabilities as a single entity would clearly allow them to have in mind potential use cases of increasing their potential. So specifically talking about technologies, we might name a few, but the essence of it is allowing the different areas in a manufacturing company to work together with the same goal making the use of most of the resources, computing resources available in the company. And this is also closely related, if I have a couple of more minutes, closely related to concepts that are already being going on in the manufacturing field during the last years, like digital twin or zero-touch manufacturing. All of these trends of, although including the human in the loop, is little by little automating more the decisions that I've taken, both in manufacturing side and also computing mindset. This also will help to dramatically increase these capabilities, according to us. And that is what we try to do and we fight for doing in the use case that Maria, Walter, and Eneko represent today here. And we will be happy to share more details about it and about the edge native technologies application as soon as we will be progressing in this very use case.
Thanks, Nacho. So we have listened to many interesting and promising perspectives from a technological point of view, but we are not dealing only with technologies. We are also dealing, with various people, various partners, and a value chain of actors. So I would like to ask final questions of this roundtable, starting with Maria Rossetti, to please tell us, based on your experience in MADE, how the support and the integration of various partners help the overall impact and outcome of the use case you're working on.
Okay. First of all, I would like to start with one point. I remind you that MADE Competence Center, being a competence center, is also formally a consortium, which is involving 49 partners, including big and small companies, technical providers and users, as well as university, being a technology transfer center. So the main resources that we get from our partner is, again, the competence, both in terms of competence of people, of partners that works to the use cases, as well as in terms of machinery, which is provided, which is basically provided in kind to our, also for our use case and to MADE Competence Center. If I had to make an example based on the use case part in the AerOs, I would say that the main contribution is on two levels. First of all, the technical partners support us in defining what are the main requirements, both again from the technical provision as well as from the users, from the usage of the platform, which support us for the, let's say, installing and even optimizing the solution itself. And of course, let's not forget about the ecosystem part, because MADE, being again a technology transfer center, is able to gather the perspective of different end users, and thus providing feedback on the let's say technology and market application of the activities itself, which basically can support also the gather of information and optimization, and possibly the solution of some of the challenges that have been exposed before by Alissa and Eneko. Basically, that's it. Of course, I could say here, speaking for regarding the benefits for several times, but I would say that this is.
Thanks, Maria. So very last few minutes of this panel and the event overall, I would like to ask Alissa as a concluding question. We have mentioned, many topics, many technologies, and from a manufacturing value chain perspective, how do you see all these emerging technologies that have been mentioned, so 5G, AI, data spaces, cloud edge, etc., to contribute to the transformation of manufacturing value chain?
Yes, well, thanks to this technology, we can collect the data concerning products and services throughout the whole product life cycle. We can also extract information from this data thanks to the AI, and we can share this data thanks to data spaces. From a manufacturing value chain point of view, I think that these enablers gain even more significance if we think about paradigms such as circularity and manufacturing as a service. So of course, all this data, all this information we can extract can support us in improving the performance of this product, in improving maintenance and production planning. But thanks to these paradigms, we could actually also achieve a sustainable manufacturing ecosystem, which is one of the main goals of our network right now.
Thanks, Alissa, also for being very, very much on time. So it's the last minute of the event. I would like to take this opportunity to thank all of you speakers. So let's give a virtual round of applause to all of you here, but also an applause to all the audience and people that were here with us, that shared some insights and comments and contacts also in the chat. The recordings will be available by tomorrow on EUCloudEdge-IoT website, so feel free to go there and check when it's out. And thanks again. I wish all of you who are starting maybe soon your holiday, happy holiday break. If not, happy work as well. And so we will meet again in the next events. Have a good afternoon.